Okay, so processing. So here is processing. This is 3.0.1. Here's the sketch opened. If you've ever run if you've ever run Arduino before, this will look very similar. So the code for processing in C++ are very similar. So I'm just going to, man, this is terrible. Emacs, never take your hands off the keyboard. Okay, so I'm going to just copy this directly into here. It's going to freak out because processing isn't exactly like C++. So let's just go through some of the things that are different. So first of all, get rid of all that. There is no namespace standard. I think these are all fine. These function routines. Missing right curly brace. Why would you say that exactly? I'm a little confused here. Let's just move on. So there is no int main. There is what's called a void loop. Processing is a drawing routine, and so there's a void loop, and it loops over and over and over again. Cout doesn't exist, but guess what? Printf does. So that's all well and good. Double x0 is no problem. There is no such thing as input arguments in processing. I mean, when you run it, you hit play here, and so really we're just going to have to hard code this. When you make pre-allocated variables here in processing, what you actually have to do is do x iters equals new double 100 like this. So it's a little bit different. I just hit save, so it's asking me to save here. I'm just going to put it on the desktop so it's ready to go. I don't know, what do I want to call this? Newton-Raphson. Okay. Let's see. This is all well and good. Int counter 0 is good. The function is good up there. Cout is good there. Oh no, wait, you can't do cout anymore. So we have to do printf in here, and then equals. Alright, we're gonna do %lf. Oh, and there is no printf, isn't there? It's just print. And then the cool thing is you can actually add strings together. So I want to say string of x of error plus /n, like that. I don't need a system call because processing has built-in plotting. Oh yeah, by the way, so there's a void loop, but all of this is actually, there's also a void setup. And so all of this stuff that I'm doing, I actually only want to do once. So I actually want to put this in the void setup routine. We'll do the void loop routine later. So I only want to do this once. So it's going to do all that. I don't need to do any output file stuff. So here's the while loop. So here's the end of the void setup routine, all of this stuff, getting the initial conditions, making my vectors. The problem is that I don't think the setup routine and the void loop routine play nice with each other. And what I mean by that is, let's get rid of this fclose all and system. If you notice, like if I scroll over here, it's going to say the variable error does not exist. So unfortunately, what we need to do is we actually need to make some globals. And so we'll come up here and we'll go double x0, double x iters bracket equals new double 100. So we're going to make them globals. Let's see, int counter equals 0. Can I do equals 0? I'll just leave it there and just get rid of this here. And then double error. So that'll get rid of this. That'll get rid of this. That'll get rid of this. That'll actually get rid of this entire line of code. There is no fabs. It's just absolute value. There's just print, and I can actually do print line, so I don't have to do /n. I'm going to just print that. I don't need to print to a file. This is fine, I think. Let's see if that works. So here's the only problem with between C++ and Fortran. Everything needs to be a float, not a double. Because because this routine power takes floats, and so I don't really know the exact difference between a double and a float in processing, but I don't really want to look it up, and I don't really care. So I'm just going to make everything a float and be done with it. And then we're going to run this, and here we go. Let's see if it works. Open a default window. Initial error is 361. And then what? Is it running this? What's happening here? Print line looping. It looks like it never got out of the setup routine. So one thing that you need to do is you need to tell the computer, like, hey, I want a window of size. I'm going to just do 600. Oh, and it's not using C++. It's oh, I'm getting Arduino and processing confused. It's not a void loop. It's a void draw. I'm sorry, man. This is the problem with knowing too many languages. It's a void draw loop. Yeah. There we go. It's looping. Okay, so we can get rid of that now and run it again. And so it ran once, but if you notice before when I had void loop, it was looping over and over and over again. So this void loop actually runs all the time, and so it's actually sufficient to just put an if statement here, and then it'll actually just run the code anyway. So an if statement and a void draw loop is the same thing as a while loop in processing. And so that's really it for processing. So like I was saying, I mean, the code it's pretty similar to C++. I guess the only differences were like where the variables are defined, the setup and the draw routine, the if statement, and then the fact that they are floats instead of doubles. So let's see. What do we want to do? We want to plot this, right? So that's really why processing was invented. And so what I'm going to do is I'm going to do ellipse. And so an ellipse takes in the x coordinate, the y coordinate, and then the radius and the I forget what the second two numbers do. It's radius and something else. But anyway, so I'm going to make a float x. I could make it the counter, which would give me kind of an x-axis, but because the size of the thing is 600, I'm going to do 10 times counter. And then for the float y-coordinate, I essentially want to just do the x iters of, and I'm going to do -1 because I did counter plus up here. And again, I'm going to multiply by 10 here. And then I'm going to run that. And then what I should see is ellipses. Now, if you notice, the whole thing is like inverted, right? I mean, that's like y is positive, and the reason why is because these are actually pixel coordinates. And so in pixel coordinates, it's 0, 0 up here, and then 600, 600 down here. So what I'm going to do is I'm actually going to do 600 minus 10, and then run that. And then there you go. And you can actually watch it in real time if you want. You can put in a delay 1 second here if you want. Is it delay? Yeah. Ooh. That must be microseconds. 1,000. Boom, 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 boom. And you can actually watch it in real time, which is pretty neat. If you want, you can like totally mess it up too, and you can say like, you know, let's get rid of this delay loop here. Well, we'll do a smaller delay loop. No, I'm just messing around at this point. And then we can do else. Ellipse, mouse x, mouse y, 5, 5. And so while it's running, nothing happens. But then once the simulation is done, then I can like put ellipses there with my mouse, which is pretty cool. Yay. Anyway, there's processing for you. So now what we're going to do is we're going to do Arduino. And Arduino, we're actually going to be able to copy and paste this code almost identically. I think we just need to change draw to loop. And I'm going to get rid of this. Well, I'll get rid of that. I'll keep it there. I think the print lines are going to change. A couple things are going to change. It's no big deal. Okay, so I'm going to save this and stop it. And then here we go for Arduino.